Hello everyone and welcome back to my channel. Imagine an AI that not only answers your question but also reason and take action. That's the power of ReAct, an excellent approach that bridges the gap in large language model. While large language model excel at answering question and text generation, they often struggles to collect information, make inference, and take meaningful actions. ReAct changes the game. It empowers large language model with reasoning traces that guide their thoughts and actions, allowing them to complete complex tasks beyond just simple responses. ReAct seamlessly combines reasoning and acting, which enables large language model to reason, act, and collect information to complete a task. In today's video, we are going to explore how ReAct empowers large language model and changes the future of AI. So, without any further delay, let us get started. So today's video is divided into 5 parts. The first part is we are going to discuss what is a LangChain agent. Second part is we are going to create a LangChain agent. The third part we are going to discuss what is ReAct agent. And fourth part we are going to create a ReAct agent, and in the final part we are going to test the ReAct agent that we created. Alright, so let us now start coding our application. Alright everyone, let's now start coding our LangChain agent today. Okay, so the first step is to install the required libraries, which are openai, LangChain, python.environment. It's already installed in my machine. Next, we are going to check what is the LangChain version, so that you can compare which version you are using. And then we are going to load the environment variable. Specifically, we are going to load the openai API key. Alright. If you don't have an account or don't have an OpenAI API key, you have actually to create an account in OpenAI and generate an OpenAI API key and load it to your environment. I'm going to leave a link to my previous video where I explain how to load the environment variable in the description of this tutorial. Okay, so now let's start with the first part by discussing what is LangChain agent and create a LangChain agent. Alright. So what is a LangChain agent? If you have used ChatGPT before, I'm sure you have come across some plugins that help GPT-4 browse the internet and access updated information, such as Canva plugin, where we can send a prompt and it will generate for us an image with a link to the Canva account. Okay, these plugins are external tools, okay, that are similar to LangChain agents. So LangChain agents provide large language model with access to external tools. Using LangChain agent, we can create tools that allow large language model to run code, do calculation, search the web using different search engine, and even run SQL queries. And this is totally different than what we have in LangChain chains, where in the chain we will have a sequence of actions that is hard-coded in our code. Alright? Using LangChain agents, the large language model are used as a reasoning engine to determine which action to take and in which order. So agents make LangChain so useful as they combine LangChain tools and chain at the same time. So agents are made up of tools and chains at the same time, and this will allow the large language model to think which one to use. Should it use the tools or should it use the chain, and so on. Okay, now let's start the code and then you will understand with me. So this agent that we are going to create will generate Python code to calculate an answer. and it will run the code in a Python interpreter. So to do that, first we have to install a package called LangChain underscore experimental. So we'll say pip install quiet LangChain underscore experimental. Okay. So this agent will accept as input a prompt from the user, and then it will generate Python code, and then it's going to run it in Python REPL environment. Okay. This LangChain experimental library, it is intended for research and exploration, and some parts are not yet stable or secure for production use. You have to be careful using it, okay? Here we are just going to use it just to as a demonstration of LangChain capability. So next after this, we are going to import the required libraries. So we'll go to LangChain underscore experimental dot utilities. And then we are going to import Python REPL class. Let's run the code. This Python REPL class will allow us to execute Python code within the REPL environment. Next, let's just create an instance of this class. So we'll say Python underscore REPL is equal to Python REPL. Okay, by this we created an instance of this class. Now let us test this class. Okay, so we'll say Python REPL. I made a mistake here, not reply without a y here. Enter. Again here, I'm gonna fix it. We'll say is equal to or not equal dot run the following code. We'll type here some Python code. We'll say import date time and then print date time dot date time dot now. Okay, I have a spelling mistake here. It's date time. So let's run the code again, and it gets the current date and time. So everything is working so far. Till now we did not use large language model. Okay, so let us now start creating the agent. And in order to create the agent, we have to import the required libraries. So first we will go to LangChain underscore experimental dot agents dot agent toolkits, and then we are going to import create underscore Python underscore agent. Also we are going to go to LangChain underscore experimental dot tools dot Python dot tool, and then we are going to import the Python REPL tool. And from LangChain underscore openai, we are going to import chat openai. Let's run the code. We have no error. So these are the required libraries that we need for this agent. We are importing a function called the create Python agent to create a special type of LangChain agent that allow us to interact with Python code. After that, here we imported the Python REPL tool class. This tool provides a Python REPL environment within the engine, allowing the agent to execute Python code directly. And finally, here we imported chat openai to create the LLM. Okay, let us now define our large language model, which is equal to chat openai model. It's equal to GPT-4 turbo preview. I'm using GPT-4 turbo preview, but feel free to use anyone you want. And for temperature, I'm gonna set it to 0. Okay, let's run the code. It's working. After that, we are going to create our agent. So we'll say agent is equal to create underscore Python underscore agent. Okay, The constructor of this create Python agent class, it takes three inputs. The first is the LLM object, and then the second is the tool, which is equal to Python repel tool, as I said, which allows us to run the code directly. And the third one is verbose. Let us set it to true to check the log, okay? Let's run the code. Now let us test the agent. So we'll say agent.invoke the following. Calculate the square root of the factorial of 10 and display it with 4 decimal points. Okay, let's run this code, and we can see here the log entering new agent executor chain. So from this code we can see how the large language model generate Python code. And as we can see here, the large language model makes a plan, then an observation, and finally a thought. And at the end, we receive the correct answer. Okay, let's try it for another command. So let's say agent dot invoke what is the answer to 3.14 start 8.2. Let's run the code again and check. Makes a plan and it gives us the answer. If you want to extract the input and output, we can say the following. We can say response is equal to, let's copy this code. Let's run it. Now we can say print response input if we want to check what is the input to get a clear output, and then we'll say print response output, and this is the output. Okay, I meant to put the verbose here to true so that you can see now with this agent it gives the large language model a way to think and make a plan what it's going to use. Okay, so this is just a simple agent. Of course we can add more tools to it so that, for example, we can, instead of passing here one tool, we can make a list of tools, and this is what we are going to see in the React agent. Okay, so that's it for this part. Next we are going to discuss what is a React agent. So what is React? As LangChain agent are one of the key components that makes LangChain useful, ReAct, which stands for reasoning and acting, combine LangChain tools and chain into one agent. ReAct acts as a powerful tool to unlock the full potential of large language model by enabling them to reason, act, and interact with the world, and also enhance their accuracy, adaptability, and interoperability, and also paving the way for building truly intelligent and interactive agent. The big problem we face when using only tools or machine is that we probably won't want to use the same tool with every query we send. Using the React agent will first check the input query entered by the user, and then decide the best tool based on the user query. By combining the strengths of large language model with React's reasoning and action capability, we can push the boundary of what's possible, and we can then create an innovative application beyond simple text generation and summarization. Now let's start creating React agent. First we have to install LangChain Hub. So we'll say pip install LangChain Hub. LangChain Hub is for sharing and discovering resources related to LangChains. It stores and allows access to pre-trained prompt, chain, and agent that can be used in LangChain project. Okay. After that, we will import module for prompts. We'll say from LangChain.prompts import prompt template. And then we are going to import the hub, LangChain import hub. Next, we will import the tool, agent executor, initializer, and creator. So we'll say from LangChain.tools, .agents, import tool, agent executor, initialize underscore agent, and create underscore react underscore agent. Okay. Next, we are going to import two libraries which I showed you in my previous video in my channel how to use them, which are DuckDuckGo search run, Wikipedia query run. So we'll go to LangChain.tools, import DuckDuck search run and Wikipedia run. And in order to use the Wikipedia query run, we need the Wikipedia API wrapper. So we'll go to LangChain.utilities and say import Wikipedia API wrapper. Next, we want to import the Python REPL tool. So we'll go from LangChain underscore experiment .tools.python .tool import Python REPL tool. And finally, we are going to import the chat openai. So we'll say from LangChain underscore openai import chat openai. Let's run the code. I hope I did not make any spelling mistake and no error. Now let us start creating our large language model. So we'll say LLM is equal to chat openai model underscore name is equal to GPT -4 -turbo -preview and temperature equal to 0. Okay, let's run the code. So what we are creating now is an agent that has multiple tools. Okay, and based on the user prompt, this agent will choose the best library or the best tool to use. Okay, now let's prepare a prompt template for asking question. Okay, so we'll say template is equal to answer the following question as best you can. And we have questions equal to question. Okay, this template will structure the way the questions are presented to the agent. So here we ask the large language model to answer the question as best as it can. All right. Next, let us convert the template into a usable format. So we'll say prompt underscore template is equal to prompt template dot from template, and we pass the template that we create in the next step. After that, we'll say prompt is equal to hub dot pull, and here we should type exactly the hub name React. So here we first convert the template into a usable format, and then here in the second line we are retrieving the structure of the React prompt from the online hub. hwchase17/react is the name of the repository, which is an object of the type prompt template. Let's run the code. And it's working, no errors. In this example agent, as I said before, we are going to use three tools: Python REPL tool for executing Python code, the Wikipedia tool for searching Wikipedia, and the DuckDuckGo search tool for generating web searches. The agent will choose the best tool based on the user input query. Okay? Since here we ask him answer the following question as best as you can. So let's start with the first tool. So here we'll say the first tool will be Python REPL tool. Okay? We'll say Python underscore REPL is equal to Python tool, and then we'll say Python underscore REPL tool is equal to tool. So here we created an object of type Python REPL tool, and then we call the class constructor. And the next line we created the Python REPL tool, which is equal to tool with the following argument. It takes three arguments: the name, which could be anything, we'll say Python REPL, and then the function, which is equal to Python REPL dot run, and the description, use one you need to run Python to answer a question. You should input Python code. Let's run the code, and it's worked, no errors. So this is the function that we are going to run when using this code, and this description is the description of the tool. Now let us create the second tool, which is Wikipedia tool. Say here Wikipedia tool. I have already explained this in my previous tutorial. Please feel free to check it, and I will leave a link to it in the description of this tutorial. So first we are going to create the API wrapper. API underscore wrapper is equal to Wikipedia API wrapper, and we are calling its constructor. After that, we are going to create an object of the Wikipedia query run. So we'll say Wikipedia is equal to Wikipedia query run, and we pass the argument, which is API underscore wrapper equal to API wrapper. And finally, we create the tool. So we'll say Wikipedia underscore tool is equal to tool, and it takes three arguments. The name, we are going to call it Wikipedia, and the function, which is equal to Wikipedia dot run, and the description, which is equal to use for one you need to look up a topic, country, or person on Wikipedia. Alright, let's run the code, and it's working. Now let us start writing the code for the third tool, which is DuckDuckGo search. So here we'll say DuckDuckGo search. Alright, same as in the previous step, we'll start with the constructor. We'll say search is equal to DuckDuckGo search run. We'll create an instance of the constructor, and then we are going to define the tool DuckDuckGo, and let's say tool is equal to tool. It will take again three arguments. The name is going to be equal to DuckDuckGo search, and the function is equal to search.run, and description is equal to use for one you need to perform an internet search to find information that another tool cannot provide. Okay, let's run the code, and it's working. Now in this step, we are going to collect all the tool into a list. So we are going to create a list of these tools. So we'll say here, tools is equal to Python underscore repel tool, and then Wikipedia tool, and finally go tool. Okay, now we can create the agent. To create the agent, we have to do two important steps: load the tools and initialize the agent. So we'll say here, agent is equal to create React agent, and we are going to pass the LLM object, that list of tools, and the prompt that we define. And initialize the agent, we'll say agent underscore executor is equal to agent executor, and this will take the following argument: agent, which is equal to agent, which is the agent returned by the create React agent function here. Okay, next, tools, it will take the list of tools that we created above. Let's set verbose equal true to see how it's working. And the next two arguments are very important. Let me type them and then I will explain it to you. We'll have handle underscore parsing underscore error equal true, and then maximum underscore iteration is equal, let's say, 10. Okay, this executor will examine the input and determine the best tool based on the user query. So it will determine which is the best tool to use, whether it is the repel tool or the Wikipedia or the DuckDuckGo search tool. Now let me explain these last two arguments that we typed here. The handle parsing error, it controls how the agent executor handles potential parsing error that might occur during the execution of the tool or the agent itself. If it is set to true, the executor will attempt to gracefully handle parsing errors by logging the error message for debugging purposes and continuing with the execution process and potentially skipping the affected tool or part of the agent response. It will also try to recover and proceed with the remaining steps. If it is set to false, which is the default value, parsing errors will cause the execution to stop immediately. Raising an exception using this argument can make agent more robust and less prone to unexpected failure due to parsing issues, especially when working with external tool or unpredictable input. Max iteration, which is here the last one, I set it to 10, limits the number of iterations or steps an agent can take during a single execution. Using this argument prevent agent from running indefinitely, which could lead to performance issues, resource exhaustion, and getting stuck in loop. Once a specific number of iteration is reached, which is in our case it is 10, the execution will stop even if the agent hasn't fully completed its task. The optimal value for maximum iteration depends on the complexity of your task and the expected execution time. You might need to adjust it on the specific use cases based on testing the agent. So let's run the code and make sure everything is working fine. And it's working fine. By this, we have successfully built the React agent. Now let us test this agent. So for testing the agent, first we are going to ask it now a programming question to see if the agent will use the Python repel tool. Okay, so let's put here question is equal to what are the next 10 numbers in the Fibonacci sequence starting from 5. So this is our question. Next we'll say output is equal to agent executor dot invoke input prompt template dot format question equal question. Here we use the executor to invoke the agent with the question. And as you can see, the argument to invoke method is a dictionary here. Okay, the key to the dictionary is the input, and the value is the template that formats the question that the user asks. So let us run the code now and check the log. All right. We can see from the log that the chain of thought in the debugging code. And as we can see here, it uses the Python repel tool, which is the write tool. And we can see here that it generates the 10 number in the Fibonacci sequence. All right. Now let's try a current event question to see if the agent will search the web using the DuckDuckGo. Okay, so let me copy this code here. And let us ask a current question. For example, I prepared a question. Let's say, what new scientific discoveries have been announced this week? Okay, let's run the code. This now it's supposed to use the DuckDuckGo search engine. Okay, let's run the code. And as you can see, it chooses the correct tool here. And it uses this DuckDuckGo search engine because it needs up-to-date information. Okay, now let's ask another question, something related to history, so that it will choose the Wikipedia tool. Again, let me paste here this following code. And I prepared the question about history. Let's say, tell me about Thomas Edison early life. It's supposed now to use the DuckDuckGo search engine. Let me scroll a little bit and run the code, entering agent execution chain, and it uses the Wikipedia tool. It has chosen the Wikipedia tool. As we can see, the agent was successful in all three scenarios. It chooses the right tool for each question and getting the answer right. By this, we reached the end of this tutorial, and we saw how we could create a multi-tool agent for large language model to allow it to reason and act based on the prompt entered by the user. If you want to learn more about LangChain, you can check my playlist and my channel about LangChain, where I created several videos about creating different applications related to LangChain. So that's it, guys, for today's video. I hope you learned something new and benefit from today's tutorial. If you have any question or feedback, please leave them in the comment below this video as usual. And if you enjoyed this tutorial, don't forget to share, like, and subscribe. Alright, see you in the next video.